Hello everyone, let's go over right triangle altitude theorem. So our first question is, in the following diagram, right triangle ABC, the altitude has been drawn from vertex C to the hypotenuse, creating two additional right triangle ACD and CBD. So what happens is you have a big triangle, so I'm going to keep that like the original black border triangle, and then you end up creating two smaller triangles, a blue one and a pink one. When you draw an altitude from the big triangle vertex to the opposite side of its hypotenuse, you end up creating two similar triangles, and we're going to try to prove that. So this is my altitude CD. The first question asks, why can you argue that triangle ABC is similar to triangle ACD? Likewise, ABC with CBD. So CBD is our pink one, and ACD is our blue one. So I'll keep those in the same color so we can see it. So let's do it with the first pair. In triangle ABC, it's angle C that is the 90 degree. And then in our triangle ACD, it's the angle D that is the one that is our 90 degree. Now, in both of the triangles, they use angle A is congruent to angle A, so that could be our reflexive. So with that situation, we end up having angle-angle similarity between the main big triangle and the blue triangle. Now, let's take a look at our pink triangle with our original black triangle. So we have triangle ABC with triangle CBD. In triangle CBD, D is the one that is our 90 degree. Look how angle D, or like the bottom right hand corner for each of these triangles, the 90 degree lines up nicely for all of them. And then between the black triangle and the pink triangle, we have angle B that is our reflexive. So I can say that angle B is congruent to angle B. So we can say this is also angle-angle similarity by having reflexive postulate with angle B is congruent to angle B. So that is our angle-angle similarity. Now, in that situation, we can discuss like how are the pink and the blue triangle are congruent to each other. So that brings us to our second question. So to make sense out of that, we can go ahead, put in the missing angles. So like the bottom right hand corner for all of them are 90 degrees. So we have 90 degree here and then 90 degree here. We had 90 degrees for all of them. Now take a look how angle B is congruent to angle B in the pink triangle. So let's say I had said that angle B is, I don't know, 60 degrees. Then this angle B would also have to be 60 degrees because those are both reflexive. And by using the corresponding angles of similar triangles are congruent and also the triangle sum, I can say that, hey, angle C has to be 30 degrees. Then so does technically this angle A because those are congruent to each other. And that also would work out here as well. So using that corresponding angles of similar triangles are congruent, we can say that this angle C is congruent to this angle B, and this angle C is congruent to this angle A, and then we can say this is angle-angle similarity. And we had to draw the two smaller triangle in the same orientation as triangle ABC. And we did that in previous part A. So we can say that this is ACD, and then we have CBD. Now, I don't know if you realize it, that this is 90 degree, this is 90 degree. And I know it looks a little bit funky because we are used to having the 90 degree in like the bottom left-hand corner. But in the triangle, the blue triangle, our hypotenuse is AC. Oops, spelled it wrong. And in our pink triangle, our hypotenuse is CB. However, if you take a look, both of them have this common side that is CD and CD, but they are not the corresponding ones. Corresponding to CD is actually BD, and from, if I look at it from the point of view of like the bottom to the bottom, and then like our diagonal to the diagonal. So that's a little bit tricky part to remember, but it also actually helps us out when we set up a proportion. We're going to see that more in like the later example. So let's take a look at AD equals to 8. And so let me substitute these things in. AD is equal to 8. BD is equal to 2. Then we have to find CD and BC. So let's call CD our X and BD, and BC, sorry, BC is our Y. Let's see, did I put everything in correctly? AD is 8, BD is 2. Let's see if we could substitute something else in. Oh, we can. CD is X here, so that means in the other one, CD should also be X. So we can actually set up a proportion. We can do 8 over X, so we can say AD over CD is equal to CD over BD. So this is X over 2. And this is what I used to set up the proportion. So I did the blue triangle over the pink triangle and the pink triangle. Notice how like diagonally you have X on both sides. I know like the corresponding side-wise they don't match up, but like the number specifically wise, they're the same thing. So 8 over X is equal to X over 2. That gives me 16 is equal to X squared. So that would mean X is equals to 4. That is our final answer. And nothing else needs to be taken care of. So find the length of CD. So CD for us is 4. So let's go ahead and replace that. Ooh, erase too much. CD is equal to 4. And they also wanted BC. Let's see how we can find BC. BC, we can use Pythagorean theorem to find it, because let me redraw this triangle where we have the 90 degree right here. So this is D, and then we can say this is C and this is B. So across from D is our CB that we don't know. We are calling this our Y. CD is 4. And then BD is 2. So we can do 4 squared plus 2 squared is equal to Y squared. That gives me 16 plus 4 is equal to Y squared. Y squared is equal to 20. Then Y would be equal to radical 20. That is radical 20 breaks into, let me do it over here. Radical 20 breaks into radical 4 and radical 5, which is 2 radical 5. And that is our final answer for it. All right, so it was a lot of like geometric conceptual situations. So let's apply some algebra to it. The right triangle altitude theorem also has something called a geometric mean. What it says is, if you draw the altitude to the hypotenuse of the right triangle separates the hypotenuse into 2 segments, not just one segment. So look, in the main triangle, we had 1 segment for the hypotenuse in the blue triangle and the other one in the pink triangle. So we broke it into half. In proportion, when we set them up, the length of the altitude is the geometric mean between the length of the 2 segments. And I know it sounds a little bit wordy, but let's do a little quick review of our means and extremes. So if I were to set up like the fraction that you see as a ratio, so like A to B is equal to C to D, I just set this as a ratio. So the ones on the inside is our means, and the ones on the outside are our extremes. And in this situation, they say that whatever is our means, they would always be the same number. So that's what our geometric means mean. So when we cross multiply, the means are diagonally. So I could do 32 over x because we don't know what it is. And it'll be x over 2. That ends up giving us 32 times 2 is 64. So x squared is equal to 64. That would mean that x is equal to 8. Now, you don't have to do diagonally this way. You could do the other diagonal too. So you could do x over 6 is equal to 8 over x. So this is still diagonally as well. This way works, but I like this first option better. In my opinion. So we have 8 times 6 is 48, and then we have x squared. So because we end up having the variable on the left side and I'm too used to having it on the right side, perfect square that goes into 48 would be, I think it's 16. Let me double check. Yes, it's 16. So we have radical 16 and radical 3, which gives me 4 radical 3 is equal to x. And that's my final answer. Okay, let's try another problem. All right, so this one I drew out a little bit for us. So they said draw the two smaller triangles in the same orientation as RST. So I gave them a little bit of like angle measurements to make our life just a tad bit easier. So I could see it a little bit more visually. So let's see. We have 90 degree, 90 degrees. So I put the 90 degree on the top thing. So we have, and then I gave them some, like I made it into a 30, 60, 90 triangle. So I said that this is 30 degree. And then I also call triangle, okay, so this is 90 degrees. So the leftover have to be 60 because it's a 30, 60, 90 triangle. So that's my green triangle. So let's try green this time. And the other one, let's call it purple. We also have a 90 degree situation here. And originally angle R, the whole angle R is equal to 90 degree. So if one little portion is 60 degree, the other one would have to be 30 degrees. So this right here is 30 degree. And if I look at from the point of view of just the purple triangle, then we have this as our 60 degree. Now, with that being said, we can draw the diagram where we match up our angle measurements. So if the angle measurement's not there for you, you can do a hypothetical situation. Another thing I do is I know that angle U is our 90 degrees, so I place that there. Now from there, I know that our altitude is RU. If my RU is, let's say, on the left side for one of the triangle, then for the other triangle would have to be on the right side because corresponding altitude is not the corresponding side for both small triangles. So you could use that also another way of labeling. With that being said, we have some missing measurements to find. So for RU is 10 and TU is 5, and we can go ahead set up a proportion to find it. And I'm just going to do 5 over 10. So this 5 over this 10 is equal to 10 over x. And look, our geometric means line up. So we get 5x is equal to 100. So x is equal to 20. That's our final answer. All right. Let's use what we just did right now for our next problem. So if I want to do another corresponding side situation, so let's say I drew these two triangles. So I have A, D, C, and then I have C, D, 12. So this is X, and this is X, this is 9, and this is 12. Now, if I want to do this, oh no, this color is overlapping it. Let's say I want to do this 9 over 12. Nope, can't do 9 over 12. If I do 9 and I want there to be a corresponding situation, corresponding will not be this bottom 12 one. Oh, I labeled something wrong. This is B. Because the altitude cannot be the corresponding side for both of them. It would have to be x is equal to x over 12. The reason why it may look like 9 and 12 is corresponding is just because I just winged it and I drew it just by looking at it, but the orientation for the triangles are not correct. So in this situation, we have a little bit of an easier way of doing this. We call it the altitude leg rule. So it's always leftover altitude is equal to altitude over right. Or I also call it the heartbeat situation. So I don't know if you have ever seen like heartbeats, they kind of go like this. So I start at the left, go up to my heartbeat, and then my heartbeat comes down over 12. And look, we have our geometric mean. So we get x squared is equals to 9 times 12, which gives us 108. And that we are going to go ahead and take a square root. X is equal to square root of 108. Let's see a perfect square that goes into it. I believe it has to be, let's see, I'm going to keep doing it. It's not 16, it's not 64. Let's see, what else do I have? Maybe 36. Yep, works out. So you have to try one at a time. 36 times 3, so the answer is 6 radical 3. All right, let's take a look at B. So for B, same thing, I'm going to do my heartbeat. Left over 12 is equal to 12 over x. I'm going to multiply 8x is equal to 144. That gives me x is equal to 18. Okay. Now, we're done with the altitude ones. Our next question, we have to use our next rule, which is hypotenuse over leg is equal to leg over part. May seem a little bit complicated, but we're going to figure it out. So let's do this. Hypotenuse over leg is equal to leg over part. So when I say hypotenuse, I'm going to look at the hypotenuse of the big triangle. So for the big triangle across from 90 degrees, my hypotenuse is this whole line, which is 12 plus 2 is 14. And the leg of this big triangle is x, not 2. 2 is part of it. Hypotenuse over leg is equal to leg over part. Now for the part, we take the one that's closest to the x, or the one we said that it might reflect over. So like if I take this green line, it's going to reflect over this bottom situation, which is 2. And then we cross multiply. X squared is equal to 14 times 2, which equals to 28. We take a square root on both sides. X is equal to, I believe it's perfect square, 4 gets into it. 4 and 7, which is 2 radical 7. All right, let's do the next one. The next one we have is 8, and then we have to find GH. So let's call GH our X, HK our Y. We are given the entire line is 32. Part of it is 8. So let's see, the other part will be 32 minus 8 gives us a 24. So I'm going to call that my 24. So we're not using altitude at all. So let's use our hypotenuse over leg is equal to leg over part. So let's try to solve for x first. So x is part of our x is a leg. So our hypotenuse, our big hypotenuse is 32 over the x, and we're going to do x over the part. So the part that reflects with x is 8. So we have x squared is equal to 32 times 8 is 256. And I believe it's a perfect square. So that would give me x is equal to 16. All right. Next one, let's solve for our y. So for our y, we're still doing hypotenuse over leg, but now our new leg is y, it's not x. So we are going to do 32 over y is equal to y over, so now our part is a different part now. This is the one that is going to reflect to or project to. It's 24. So we're going to do 32 times 24. That equals to 768. And we're going to take a square root of that big number. I believe 256 goes into it. Yes, it is. 256 times 3, which is 16 radical 3. That is our answer for y. And another way you can also check your answer. So a quick way to check our answer would be, so this was 16. Like if I take my entire big triangle and I do a Pythagorean theorem. So like if I do, so let's see, 16 square plus 16 radical 3 square, it has to be equal to 32 square. So this is 256 plus 768. I don't know what is 32 square. It is 1024. Let's see, 256 plus 768. They're both 1024. That's how I can check my answer. Let's say I wanted to find the value of this green line, which is our altitude. Just using Pythagorean theorem, I'm going to call this z. So I could do another Pythagorean theorem just by using this triangle, because right now it will be 8 square plus z square is equal to 16 square, because that's my new hypotenuse. 64 plus z square is equal to 16 square equal to 256. Z square is equal to 192. And then we take a square root on both sides. Square root of 192. I don't think there's a perfect square that goes into it. Wait, nope, I lied. I believe it's 64. It is 64. So radical 64 and radical 3. So z is equal to 8 radical 3. So anytime you feel like the altitude rule or like the leg rule is like, you know, throwing you off a little bit, you can always use Pythagorean theorem, but you just have to keep doing it over and over. It's a little bit of work. Make sure you copy down all the notes, and if you have any questions, bring it to class.